All right, so we've talked about central measures of central tendency, which is your mean, median, mode, mid-range. We've talked about measures of variation or dispersion, range, variance, standard deviation. Now we're getting into measures of position. So what happens is sometimes after you have calculated your mean, you've calculated your variance, standard deviation, sometimes it might kind of help to know if you're looking at a specific data value, you know, what's the location of that data value, what's its position. So this is where we actually get into our standard scores. Some of you may have heard it as z-scores. So we'll talk about that. Percentiles, deciles, quartiles. Technically, if you can understand percentiles, deciles is just breaking it up into counts of 10. Quartiles would be breaking it up into quarters, right? So as long as we can do percentiles, we can actually talk about deciles and quartiles. So they basically give you a relative position of that data value, you know, where in the set is going to fall. So just as an example here, they're saying if a value is located at the 80th percentile, it means that 80% of your values would fall below that data set, right? And if 80% is falling below, then that means 20% would be above. Anything that pops in your mind of where we might be using percentiles in? Grading? Not really. I mean, we can, but that's just not a general practice, but you can definitely do it with grading. Where else do we normally see it in day-to-day use? Testing, yeah. SAT scores, ACT scores, right? They will usually, and it's been a long time since I've seen one of those scorecards, but usually they tell you what percentile your score fell into, right? At least they used to. I don't know if that's something they've changed or not. Where else? Babies. Oh my goodness gracious. When my friend was going through, she has one boy, and as he was growing up and they would have doctor's visits, she had to call me and tell me he is in the 90th percentile weight, or he's in the 95th percentile height for his age group, and oh, he's growing so beautiful. You know, of course she was a proud mama. So yeah, they use percentiles to kind of see how kids are growing compared to kids their age, right? And you can actually do that for any kind of growth. It doesn't have to be just human babies, right? We try to do that if you are looking at big major farming operations and stuff like that. They want to use that. So you actually have so many different applications where we might be interested in knowing, you know, what is the positioning of our data value and where our kind of set falls. So again, as a researcher, this will be something that, you know, all of us have to be kind of mindful about when we're going through these calculations. And that little last line on that first paragraph is basically telling you when we're talking about the median calculation, that median actually falls at the 50th percentile, right? Because that's that measure of central tendency. And think about it again, when we calculate the median, we always try to find that centermost position. So that means 50% of our data value should be to the left of the median, or below the median. 50% of our data value should be above the median or to the right of the median. So like I said, the first thing we're going to start out with is your standard score or z-score. Basically, a standard score is to try and find out how far away we are from the mean. Are we above the mean? It's going to be a positive number. Are you below the mean? It's going to be a negative number. So you can kind of see this example right here. We're talking about a student that scored 90 on a music test, but 45 on an English exam. If that's the only information you know, what would you tend to think? Did they do really badly on English and really well on music? Yeah? But what if I told you that was 45 out of 50? Right? Because they're not telling us anything. So then we don't know. We can't really do a direct comparison. So in that sense, it comes into play with the idea of using your standard score and z-score. And again, as you can see from this little box here, we need to use, again, our calculations for mean and standard deviation to come up with this position. So again, remember, as I told you, you're basically trying to find out how far away is this data value from the mean. If it's positive, you are above the mean. If it's negative, you are below the mean. So again, if you're using samples, you would be using X bar and S as your variables. If you are looking at populations, you're using mu and sigma as your variables for mean and standard deviation. So let's take a look at this example here, kind of based on that testing thing. So a student scored 85 on the English test, and the mean for all these scores was 76, and the standard deviation was 4. Okay, so this particular student scored 85 on the English test, but for the entire class, they're telling us the mean was 76 and the standard deviation is 4. The same student also scored a 42 on a French test, and the class mean was 36 and the standard deviation was 3. So again, we're actually trying to compare which exam did she perform better on. You can see we're using our little z-score calculation here. So that's your data value, which would be the student's test score. Subtract the class mean, and then divide the entire thing by your standard deviation. So she scored 85 on her English exam with a mean of 76. So that's 85 minus 76 divided by the standard deviation of 4. And that's giving us a z-score of 2.25, which means compared with the mean for the class, she is actually 2.25 standard deviations above, right? Which means that's actually a good place to be. With her French test, she scored 42. The class mean was 36, and we're dividing this by a standard deviation of 3. So she's 2 standard deviations above the mean, which means she still did really well compared to the mean for the class, right? But out of the 2, which one did she do better on? English, because she is further away from the mean in this case. So since her positioning is on the higher end of the scores, she actually did better. Now again, it's not always going to be that the higher z-score means you have a better performance. It depends on what example you're looking at, what data set you're looking at. In this, of course, the higher you score, the better you do. So she did slightly better on her English score than she did on her French class. Oh, if your z-score comes out to be 0, that means you were right at the mean, right? Because you're not above or below, you're right at the mean, so your positioning is right at that halfway point. Another example here, we're talking about, in a recent study, the mean age at which men get married is said to be 26.4 years with a standard deviation of 2. For women, the age at which they get married, the mean is 23.5 years with a standard deviation of 2.3. So they want to know what the relative positions would be for a man who got married at 24 and a woman who got married at 22. Yeah. So that's 24 as the data value. The mean is 26.4 divided by a standard deviation of 2 for the men. So he's actually, obviously, since he's below the mean, at 24, you're going to get a negative value as expected. So negative 1.2. This is something I do want to make a note about. Do not switch the order. Do not try to put the mean first and then this score to get a positive answer, because we need that negative. The negative tells us if you're going to be above or below the mean. So always the data value minus the mean. So just be careful of that order. For the woman, she's also getting married at 22, which is below the mean. That's 22 minus 23.5 divided by standard deviation of 2.3, and she's at negative 0.65. So as you can see in the conclusion, we're saying the woman's age at marriage is relatively higher than the man's age at marriage, right? So in this case, the closer you are to the mean, you, I guess, got married earlier than, or I don't know if I want to say earlier, I guess relatively earlier than the man did in this case. So it really just kind of, again, depends on what example you're looking at, what kind of data set you have. So again, keep in mind, the z-score or the standard score is basically giving you how many standard deviations you are away from the mean. Sometimes you'll get nice and clean integer answers, 1, 2, 3, 4, depending on what, and then sometimes you'll get decimal answers, but that's just telling you how many standard deviations you are away from the mean. All right, let's try and find us an example for this before we continue. about, let's do number 11. You've got a couple different choices in there. Oh, didn't mean to do that. There we go. So this is again actually talking in terms of marriage age. Or you know what? Let's do vacation. So number 9. If the average number of vacation days for a selection of various countries has a mean of 29.4 days and the standard deviation is 8.6 days, they're asking us to find the z-scores for the average number of vacations for each of these countries. So you've got Canada, Italy, and United States. So they're saying the mean number of days people take as vacation is 29.4 with a standard deviation of 8.6 days. So what would be the z-score for people taking vacations in Canada, Italy, and the United States? So again, remember your formula for z-score is z equals the data value minus the mean divided by standard deviation. So for number 9, they're telling us the average from their data is 29.4 days. The standard deviation was 8.6 days. And then they're asking us to calculate the z-score for Canada at 26 days, Italy at 42 days, and United States at 13 days. So again, US is 13 days, since you can't see that part on the screen right now. Again, your formula for Canada z-score will be data value minus the mean, and that entire thing divided by standard deviation. What did we get for Canada?
-0.39.
Oh, negative 0. Since you have 395, let's go up to 0.40, negative. Alrighty. So Canada is below the mean, right? Since you got a negative value. Italy is taking 42 days of vacation. Maybe we should move to Italy. And what did that number come out to be?
1.47.
So above the mean, obviously, since 42 is a number higher than 29.4, so I'm getting 1.465, so 1.47, right? 2 decimal places. And seems to be not looking very good for the US. We're only at 13 days. And what did that come out to be? It's going to be negative something. -1.906, it looks like. We'll round it to 2 decimal places, make it -1.91. What would you conclude looking at those three different z-scores?
It's like Canada and US are below average and Italy is above.
Above average? Okay, very good. And the worst seems to be America in this case, right? Because you are -1.91 standard deviations away from the mean. And that's actually a study they have done and said that America takes the least number of vacation days, which means people here are a little bit more stressed out, work-related, because they're just not taking as much time off. And then European countries are definitely good at taking their vacation days. And of course, you can see with this data here, 42 days for Italy. India is kind of in between. So we're not as bad as America, but we're certainly not as good as Italy either. But the more vacation days you take, the more relaxed you are, the better you actually perform at your job, whatever that might be, right? What else is Italy famous for? Well, food, yeah, but relaxation-wise.
Mediterranean? Mediterranean Gulf fishing?
Yeah, definitely. No, I'm actually thinking more of afternoon siestas. They actually close stores and go to sleep in the afternoon. They used to do that in India. So from 1 to 4, forget about going anywhere, getting anything, because every store owner was going home, eating dinner or lunch, whatever, taking a nap, and then coming. My uncle had a clothing store, clockwork. 1 o'clock, the shutters were down, employees were gone. He would go upstairs to his apartment, eat lunch, sleep, then come back at 4, all refreshed, and I'm ready to go. So, it does make a difference, but we're obviously going away from all of those things. So you can kind of see just with this little example here, how different cultures do things differently. Wouldn't that be something? Like little kids in kindergarten, you can take nap in the afternoon.
I work 2-year-olds.
Oh, you do?
Yeah.
Oh, yeah. That's the best time, right? When they're asleep.
They lay down at 12 and they don't get out of their beds till 30.
Really?
Yeah.
Ooh, that's a nice nap. Maybe we should talk to Ames about that. Alrighty, guys. Any questions on the z-scores? We're all okay? Okay, so we will be revisiting z-scores chapter 6. I don't know. We'll be revisiting them when we talk about normal distribution, because this is the exact same calculation we need to do our normal distribution, which will tie in your empirical rule with the z-scores, okay? Alrighty, now we're getting into the percentile discussion. So this is, of course, as we were talking about the position. So with percentile, and you can kind of think of percentage to help you out. That is, you can see we break it up into 100 equal parts. And then the idea is, like you saw in that first paragraph for this handout, if they say 80th percentile, that means 80% of the data values will be below that that score or whatever you're looking at, and only 20% would be above. So we do use the symbols of P sub 1, P sub 2, P sub 3, all the way to P 99 to talk about, are you at the 30th percentile? So 30th percentile would be P sub 30, right? So that's how we kind of write this down. And like I said, you break it up into 100 different parts. They're talking about, see your textbook page for table 3.3, which shows the percentiles ranked for scaled scores on the test of English as a foreign language. And let me see, I thought I had pulled it up. There we go. So that's the table that they are talking about. Now, when they're talking about the test of English as a foreign language, it's for people like me who were not born in the US, but who came as students to the United States. So you actually have to take this exam in your home country and show your proficiency in English. So even though India is an English-speaking country, and English is our official language, colleges and universities in the US don't give you admission till you can show you are proficient in English. I just got really lucky because the recruiter who came to India to find students let me bypass that stage, because obviously I talked to him, we had a good discussion for about an hour or so. So he knew I could speak English. And so he waved that off, and I was like, oh, thank you, because I really didn't want to study for another test. But that doesn't happen. When my brother applied for universities, he forgot how to take his exams. So it's just anybody. Now, unless you're coming from a country like United Kingdom, which is another dominant English-speaking country, I think you don't have to do the TOEFL exam. But if you're coming from any country where the national language would be anything other than English, you have to show your proficiency. So that's actually this exam scores that they're talking about. So as you can see, you have your scaled scores on the left-hand side. So we're looking at 58 since they have an arrow marked on it. And then with each section, you would have 81 on the listening comprehension. What's that? 76 on structure and written expression, 81 on vocabulary and reading comprehension. And of course, they're scaling it all together, which gives you that 58. But then look at that percentile on the right hand side. It's 82 percentile, right? 82nd percentile. So that basically means the person who scores at 58 on their scale score basically did pretty well, because 82% of the scores would be below their score. And what would that be remaining? How many above? 18, yeah. 100 minus 82, you would have 18. And then you can kind of see the higher that scale score is, the higher your percentile rank is on the right-hand side, right? Okay. So that's what that table is basically talking about. Okay, they're also talking about looking at the percentile graph, which is the next one I'll show you. And this one is basically graphical form of weights of girls from ages 2 to 18. So that would be this little graph here. And I do not like these things. Can you tell me why this would be such a hot, holy mess? Okay, so yes, go ahead.
Is there two y-axes? Axes, I suppose?
Yeah, it does look like, but it's actually just using weight on pounds and kilograms, just to show you if you're using a different scale. But I mean, it's still weight,
Yeah.
and then the age of the, what did they say? Young girls?
Because the y-axis is way taller than 41 grams.
Not so much because of that, but you can see if you're going to be somewhere at non-marked numbers, right? So what if you were looking at a girl who was 8 years old, but then she's not going to fall on one of these curves, right? The percentile graph. So if you're at 8 years old, but you are only weighing, I don't know, somewhere in there, it's going to be really hard to read that. And I guess the idea is you can get an approximation, but you're not going to get an exact value. And then the other thing is, and we're actually going to do a brief example on this, graphing these is a nightmare also. Just because, as you can see, that's not going to be a pretty graph to try and draw either. And accuracy is always a thing. Now, I know you can use computer softwares to do graphing and stuff, so a lot of times we're not really doing these by hand, but reading is going to be so much harder. So let's say if I told you a girl, since we're talking about girls in this example, weighs 125 pounds, and then they're asking you to find out approximately based on this percentile graph, what age should she fall into. So 125 would be somewhere between 125, I mean halfway between 120 and 130, right? But then if you follow that along, and let me see if I can do this. If you follow that along, looks like this guy is not aligned again. You would have to kind of go along and then see where you hit that line, and then you would have to go down, right? Because the idea is you need to make this little connection between the age and the weight. So there, the example they're showing us that if you are looking at an 11-year-old girl, she should be approximately at 82 pounds, which will come out to be, looks like 36, maybe 37 kilograms on the other side, right? So yeah, I'm not a big fan of these, but obviously you should know this is something that they will kind of use to come up with these percentile graphs. So that's the example they're going on at. You basically kind of take those vertical and horizontal lines and see where they meet, and you will kind of be able to see where they go. Okay, so we did talk about using percentiles when you are looking at these national tests. They're talking about tests such as the National Education Developmental Test taken by students in 9th or 10th grade. Okay, you can kind of read that paragraph. So this is the one I do want you to be careful about. If you need to underline that, go ahead and underline that. Percentiles are not the same as percentages. So when you are saying 82nd percentile, that doesn't mean 82nd, 82%. Remember, that's how many data values will be below that score or number that you're looking at. So if a student gets 72 correct answers out of a possible of 100, well, then her score would be considered to be 72%, right? But when we are talking about position, we actually don't know where her position falls unless we look at the scores for all of her classmates and then kind of figure out where that percentile would be. So they are saying she could have the highest score, the lowest score, or she could be somewhere in the middle. But they're saying if you have a raw score of 72 that corresponds to, what is it, 64th percentile, then we know her exact positioning. 64% of the students scored below her, and then how many scored above her? 36%. There you go. So that's kind of what you have to think about. All righty, let's go ahead and take a look at this example. And they're actually talking about the percentile graphs use the same values as the cumulative relative frequency. Do you remember what those graphs were called when we used cumulative frequency to graph them? It is an ogive, yeah, and you can kind of see that general ogive-like shape on these, right? So that's what they're actually using, but you're doing multiple of those curves on the same graph. Okay, so we're looking at our frequency distribution here for systolic blood pressure readings, and this is in millimeters of mercury of 200 randomly selected college students. So they're asking us to construct a percentile graph. You've got your class boundaries, you've got your frequency. So of course we need to calculate cumulative frequency. Now remember, again, for cumulative frequency, you start by taking less than your lowest boundary value, which would be 89.5. We would do it for each boundary value going all the way up to less than 179.5. We start at 0 and then we start adding frequencies, right? It would be 0 plus 24, 24 plus 62, whatever that total is, plus 72, and so on. Cumulative percent, and that's the little calculation they're showing here. You would basically take your cumulative frequency, divide by the total of your frequency column, which is the n, and then convert it to a percent by multiplying by 100. So you can kind of see that calculation right here. And then here's our completed table. So the way this graph would work on the x-axis, we would of course have our class boundaries just exactly like we did with those ogive graphs in 2.2. And then this is actually your cumulative percentage, which is coming from that last column. And then based on 89.5, which was your beginning, you would be at 0. At 104.5, you would be at 12. And see, this is where I have problems with percentile graphs. Because now our y-axis is in tens, right? You have to graph 12, which means you got to figure out where that 12 is going to be. and then mark your point. For 19.5, you are at 43. So that would be somewhere in here to get that 42. So it's really something that gives you approximations, but doesn't give you very good answers. So basically that's the idea. You go all the way till you get to that 100%. And then based on the questions, you know, find a percentile for this class boundary. Or if we are looking at the 57th percentile, then what score would it correspond with? Or in this case, systolic blood pressure, like they're talking about. So what I actually want to do is at least give you guys a feel for the percentile graph. I think this is it. So they're asking us, number 19 here, the achievement test scores. The data shown represents the scores on a national achievement test for a group of 10th grade students. And they're saying find the approximate percentile range by constructing a percentile graph. So those are the questions A through E, but here's our frequency distribution. And then you can see the second part of the problem is now giving you the percentiles and asking us to find the approximate scores that would go with it. So this is the first thing we're going to actually need to do is calculate our cumulative frequency and then our cumulative percentage. So let's see if we can actually try and do that right here. So let's do our cumulative frequency next. And then we'll do our cumulative percents as the last column. So I'll give you guys some time. So let me see, how do I want to do this? And to keep ourselves at a good pace to be able to graph these, let's round all of them to the whole numbers. That'll make it easier for us to graph, because right now you're getting what, 4.166666 for the 5 out of 120. So yeah, that's going to be a nightmare to graph. So let's round it to 4% basically. What did we get for 22? 18%, and these are all rounded answers. 44 should technically be double of that, right? But with the rounding, what do you get? 37%. Okay, so that would then be 92 out of 120. And what's 92 coming out to be? 77%. Okay. 114. Okay. That's good. And the last one, of course, would be 100%. Okay. Everybody okay so far coming up with these data values? Anybody who had trouble with it? Okay. So now the boundaries, or in this case, the scores will go on the x-axis, right? So the lowest value you would be starting at is 196.5, going all the way to 322. Again, remember to equally draw these guys out. Bottom, you need them. Yeah. Sorry. Okay. Everybody else is okay? Alrighty, wonderful. So let's try and see if we can wrap this guy. Basically, you're doing an ogive. So this guy was okay. Number 19. Okay. Okay, so remember these guys are going to be our scores. And we are going from 196, and how many are those? 1, 2, 3, 4, 5, 6, 7. We've got 196.5, 217.5, 238.5, 259.5, 280.5, 301.5, and then 322.5. And since I had to erase my percentage column, we are going from 4 to 100. We've got 4, 18, 37, 77, 95. Probably better to do increments of 10, right? So we can kind of get a good spread on our Y values. Of course, you would be starting at 0% and going 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these guys are going to be your cumulative percent. What kind of title can we give our graph here?
Grade academic high school.
Okay, 10th grade academic test scores. All right, so remember at 196, you are starting at 0. And then for 217.5, you will be at 4%, right? Because you're using that last column. So 4%, halfway would be 5, and maybe a hair below halfway. Oops, wrong place. Should be here. Okay, then at 238.5, 18%. Okay, so 18% would be more than 3/4, which is slightly below 20. Oh, I wish I had a ruler. Okay, so again, we're trying to go for accuracy again. At 259.5 was 37%. So halfway would be 35. So maybe just a little bit above that would be 37%. And again, you want to make sure you are in line horizontally and vertically. Okay. 280.5 was 77%. So same thing, more than halfway between 70 and 80, but not quite 3/4 of the way, I guess. Maybe somewhere over there. 301.5 was at 95%. I might have to move my title. Nope. Come on. And then of course you will be at 100% on that last one. It's not pretty. But hopefully you guys will have a little bit of a better graph than I have here. Hopefully that gives you a general idea. May I see yours? Are you done with yours? Oh, Michael, you're really testing my eyes. Okay, at least you have the general shape of that. So that's really good. That looks good. Wrapping paper definitely helps you out a lot. Very nice. Okay. So now comes the fun part, because now that we have our little percentile curve, we now have to answer the questions, which is where we're going to need to make those little grid marks, right? So we can match our approximate value. So let me pull up that problem. If you will go ahead and write those 5 numbers down for parts A through E. So those are the scores. We're trying to find what percentile they'll fall into. So 220, 245, 276, 280, 300. And let me go ahead and write those down here for us. So 220, 245, 276, 280, 300. And then you have parts F, G, H, I, and J, which is the percentile. So that's your 15th, 29th, 43rd, 65th, and 80th. So it's actually the bottom part that I'm writing down. Okay, so if we are talking about 220 as our score, how are you going to try and figure out where that 220 is? So basically, you've got 21 values sandwiched between 217.5 and 238.5. So if you had to approximately guess, where would you put your 220 at? Yeah, I mean, honestly, it's going to be like a hair away from 217. And then the idea is, again, and you're going to need a ruler for this. So the idea is you're going to take that mark where you have 220 at, take it up vertically till you hit the curve. And then at that point, take it horizontally till you get to the y-axis. So I'm basically drawing my vertical line till I hit my curve for the ogive or the percentile graph, and then I'm going to do a horizontal. And you know, I apologize, guys. This is like a hot holy mess. But draw that then continuously to your y-axis to see at what percentage you are hitting at, and of course, make sure you're writing down your value. So that's 220. And what would you kind of guess? Remember 217.5 was at 4%? So what would you guess for this guy? 5? That's my guess. Also, is 5%, but you know, of course, your textbook is saying 6%. And this will actually be a percentile. So please make sure you're not writing it as a percent and you're putting those little TH or third or fourth or nth, the little TH. So you should write it as 5th percentile. Like I said, your textbook is claiming 6. But go with what your graph is saying, just because my graph I know is a little off. Okay. All right, we'll pick this up next time. So if you want to complete this, you can. If not, we can do this in class on Monday. So we'll finish this section. Again, once we get to percentiles, quartiles, and deciles, don't take that long. And then we'll finish 3.4, which is mainly talking about box plots. So if you can do percentiles, that's the same calculation you need for box plots. All right, guys, have a wonderful weekend. Please make sure you are working on your homework, and I will see you Monday morning.